Yeah, so I found this research a number of years ago that's really pretty fascinating. And I think we don't fully understand everything about it, but let me pull up the slide here so we can talk about it. So this is some research, relatively recent, 2006. It's a really interesting study. It's a longitudinal study. It happened over 10 years. They studied, I think it was 307 kids. Um, and what it's looking at is physical neuroscience data, the thickness of the brain cortex. Like your brain is actually a sheet, like the outer cortex layer of the brain is a sheet. You could actually stretch it out and measure the thickness of it non-invasively. That's the key for a study like this. Right? And there is a real predictable sort of developmental pattern in the thickness of the cortex that neuroscience has known about for a really long time, which you can see here kind of in that average line, right? So this chart is showing from age 7 to age 19 what the thickness of the cortex is, the thickness of the brain cortex is, and how it changes over the ages. And so for an average IQ kid, sort of the neurotypically developing student, you expect the cortex to thicken up in early childhood, to peak around age 8, that's where the chart starts, and then this process of pruning takes place, where it's kind of use it or lose it. The neurons that you're using get to stick around, the things you're not using get pruned away, the brain consolidates, it gets more efficient, it gets, the connections that you're using a lot get reinforced or myelinated. And so that's the typical brain development that we expect all people to have in childhood. Well, the fascinating thing about this piece of research is that they sorted the kids based on IQ. And of course, you see here that there is a radically different curve. Here, I'll highlight it for you in red. For kids of IQ above 121. And for those of you who know about IQ, like 120, quote unquote gifted is somewhere in the neighborhood of 130, right? So this is a pretty lightweight kind of marker, yet it shows a markedly different developmental pattern, right? Where the cortex doesn't thicken up until much later. It peaks more like age 12, so that's a 4-year difference from age 8. Right? And then the process of pruning takes place. And so this is really pretty fascinating, and I think we're all waiting for this research to get replicated, right? We'd like to see somebody else do it again. But boy, it really stirs up some thought. What does this really mean? And there's actually another set of researchers who found some pretty similar results, but they were finding it empirically, like looking at behavior, as opposed to the physical brain data. They said kids who had higher IQs to begin with seemed to have an extended period in adolescence during which they retained the ability to learn at a rapid pace, just like much younger children, right? And that sure looks a lot like this chart, right? The beginning of that red line is a really fast growth, right? Where you can imagine a lot of connections being made. Does it connect? Does it not connect? I don't know, but it's sure pretty suggestive. But I think from an executive function standpoint, I think that's where this gets really fascinating, right? Because we don't really understand enough about executive function. But people seem to believe that executive function is one of those sort of highest order brain functions that kind of comes online the latest, and it seems to be really connected with this use it or lose it, pruning process, that downward line on the graph. Right. And so if that's when kids are starting to develop executive function, that's interesting, right? And it kind of correlates with what we see in schools, right? Somewhere around age 9, 10, 11, 12, right? We sort of expect kids to be able to handle, say, a middle school environment. You're right. More classes, teachers, your own locker, take more charge of your homework, keep track of your pencils and your gear, and all that stuff. And for most kids, that works, right? However, those of us who spend time in the gifted population, like we see a whole population of kids where it doesn't work so well and executive function seems to snap in late, right? And this data might give us a reason why. right? Like, could it be that because the brain is developing on a different timetable, that's why we're seeing executive function snap in late for these kids, right?
And this is sort of this idea of twice exceptionality, that these kids are so bright and they're so quick, and you think you're speaking to a little adult. So I think it's so common for parents to have, high expectations across the board of these kids. And then you look at a chart like this and it's sort of like, okay, I'm not crazy. The executive function is coming on board later. And, it makes perfect sense seeing this.
Yeah, well, it is confusing. I think it's confusing for parents to see a kid who clearly has all this abstract reasoning, right? Who can, is the terrific little lawyer, and can just do all this crazy stuff, but yet can't keep track of their homework, right? And is piling up jackets on the playground in elementary school, right? And, just can't seem to remember to hand in their homework, and can't seem to keep track of their schedule, and can't seem to break down those larger projects into small pieces. Well, those are all executive function things. I mean, everything down to, keeping focused attention on one thing, right? Our kids are the ooh shiny kind of kids, right? And that's an executive function thing, right? Yeah. So the real danger spot, and you can see it right in this chart, is right in those middle school years, right? 10, 11, 12, when kids are likely in a middle school environment where the expectations around them are that they should really be developing some executive function, but yet our kids may really not have the hardware yet to get there.